So you've got figure 1 shows a particle of P mass 0.5 kilograms at rest on a rough horizontal plane. That means we have friction. Find the magnitude of the normal reaction of the plane on P. So the normal reaction, that's our normal reaction. That's got to be opposite to our mg. So the first answer is R equals 0.5 times g. So we get 4.9 because g is 9.8. That's 4.9 newtons, easy 1 out of 1. Now we have a coefficient of friction, that's because it's a rough plane, and it's 2/7. They're saying the horizontal force of magnitude X is applied. That means we're going to have a F max friction acting against it. And it's applied to P, but it says given that P is now in limiting equilibrium, that means it's not moving. Find the value of X. So that's quite straightforward really. You've just got F equals mu R, because it has to be exactly the same as the friction, F max, for it to be in limiting equilibrium. So we just do our 2/7 times what our R value is here, our resultant, and that equals 1.4 newtons. Very straightforward. Now question 2a, that should really be 8 out of 8. You're just using areas of this graph, just running areas underneath the curve and understanding gradient. Part A says find the acceleration of the athlete during the first 4 seconds of the race, stating the units of your answer. So we have, if this is speed versus time, then acceleration must be the gradient, so it's 10 over 4, because the height is 10 over the width of 4. Work that out, so that's 2.25 meters per second to the -2. That is worth 1 mark in itself. If you miss that out, you lose an easy mark. Part B, find the distance by the athlete covered during the first 18 seconds of the race, up to here. So essentially you're just finding the area of a triangle and a rectangle, or you can use a trapezium rule as well, area of a trapezium, because that's a right angle trapezium. So part B, split that up. You've got a rectangle of 14 times 10, you can see here, plus the triangle, which is obviously 4 times 10 divided by 2. The answer is 160. That is one of the easiest 3 marks you can get in a mechanics year 2 paper. So this shows that it's a 200 meter race in 24 seconds. So it says find the value of U. And U is the deceleration with speed U meters per second at a constant rate. So we want his speed velocity at U. So we want this. So we could possibly work this out by working out what is the distance between 18 and 24. So we know, if we work out this entire area here, we know the total distance is 200 meters. The first 18 seconds was 160. So that last 6 seconds must be 200 minus 160. So we get a distance of 40 meters. That's nice. So our U, which is given here, that's all we need to work out. We need to find out, what is this height? What is this height of this here? Alright, so we have 6U, that's our rectangle in green, plus 6 times 10 minus the U divided by 2, which gives us this triangle, if that makes sense. And that must equal 40 meters, that area we've worked out, because that stage of the journey is 40 meters. So we've got our rectangle, which is 6U, and our triangle right there. So we just need to solve for this. And work everything out. So essentially here we've expanded this out and divided it by 2 to get plus 30 minus 3u. Combine everything together and we then get 10, because we've minus the 30 equals 3u, so 10 divided by 3 must be u, and that's 3 1/3 meters per second. And hopefully this explains why the triangle is 10 minus u, because this is u, the whole distance is 10. That's the whole question, 8 out of 8. Right, class, I just want to show you how easy you can get 7 out of 7 or even gain a few marks. We've got a key bit of information. We've got mass m. It's rough, so we know we're going to have mu, or coefficient of friction, at some point. That's some key information, and we have to use this to resultant forces. So we start off drawing our nice triangle. We have our mg. We know that's our opposite, so that's mg sine alpha. That's going to be mg cos alpha, and of course we're going to have our normal reaction, which is asking, that's what we need for part A, and it says find in terms of mg. Let's work out our triangle. We can use Pythagoras to find this missing length, but we should know it's 13 by using Pythagoras if we're not sure. So that means our sine alpha is 5 over 13, opposite over hypotenuse, and our cos alpha is 12 over 13, adjacent over hypotenuse. So our normal reaction is going to equal this here, mg cos alpha. Now we know that is cos alpha is 12 over 13, so that's our answer. 2 out of 2 marks, we should all be able to do that. Now part B is where it becomes interesting. We've got to use, so what can we use related to this? That's F equals ma, and we've got to use F equals mu r. So let's put our numbers in. We've got acceleration acting this way. That's our friction. Continue our force diagrams, and we can start for using the equation of motion down a plane. That's all we need, because we're just concerned with this acceleration here. So we just look at all these forces. So 2 formulas we use. This is our friction, which equals mu r, and we have F, which means total forces, equals mass times acceleration. So what's our total forces? We've got acceleration minus our friction. Okay, so 5 over 13, we've got this, minus our friction, must equal mass times acceleration, okay, because that's what we're looking for. So this friction force here, this F is for friction, not this, equals mu r. We know r is 12 over 13, so we just use that to work out our F max. So our F max equals mu times 12 over 13 mg. Great, we can substitute that in here, and that equals our mass times acceleration, our right hand side. Good. Now can you see we can divide every term, m term, out, because m is in each term. Okay, and we're using this to get our A, so let's work that out, and that's just showing you all the things we're using. So that's going to equal our A now. Now think about how we can rearrange this to make this look like this. We can take 1 out over 13 out, and that's already done. That's our 4 out of 4 marks. State what would happen to P if it's released from rest, but mu is greater than 5 over 12. Well, if friction is greater than the force, right, mu is 5 over 12, then we know that the particle's not going to move, is it? If it's greater than the downward force. So essentially friction greater than the force is, so moving down, so will not move, the particle will not move. Hopefully that makes sense. So if you look at our orange bit here, that's our friction we're using, and the pink is our A, and our orange here makes this to work out our A. And we just substitute all the numbers in, and that is a easy 7 out of 7 once you learn how to do it. Okay, so we have a position vector R, and R equals c t to the I minus 3 over 8t squared to the j. C is a constant, and when t equals 4, the bearing of P from O is 135 degrees. Show that C equals 3 for 3 marks. We'll just think about, let's do a bearing. 90 add 45 is 135. Bearings are from north, and at that point t equals 4. Just substitute our values in to this formula here. So we get R equals 2c in terms of I, and minus 6j in terms of j minus 6. So as a triangle, imagine that as a triangle here. You've got 2ci over 6, so we just can use 2 and 6, 2c and 6. And we know that's tan 45, opposite over adjacent. So 6 over tc, 2c equals tan 45. We should know, or plug it in your calculator, tan 45 equals 1. So then we can solve, multiply out by 2c, we get 2c equals 6, and divide by 2c equals 3. That is a straightforward 3 out of 3 marks. Let's look at part B. Now remember, find the speed of P when t equals 4. We're good at this, we know it's a magnitude. But we can work out velocity by differentiating R. So we'll get some marks by doing dr dt equals v and just differentiating this correctly. Remember, we multiply by the power and subtract the power by 1. Multiply the power, subtract the power by 1. Now really, I should have substituted c equals 3 here, but I'll just do it right now because we'll get the same answer, and we get this answer here. Now that's our velocity, but it's asking for the speed of t when P when t equals 4, right? So when use t equals 4 and for the I and j components only, and use Pythagoras. So essentially I'm substituting 4 into t for I, which becomes 3 over 4 squared. Put t equals 4 here in the j component, plus minus 3 all squared. Square root it all, do that on our calculator, but write this down for our method marks, and we get a final answer like so. That's a straightforward 4 out of 4 marks. Lots of you are very good at this, so I can go through this quickly. Now C is where we lost marks. When t equals capital T, P is accelerated in the direction of minus I minus 27j. Find the value of t. Let's earn some marks. We know if we differentiate velocity, we get acceleration. So we just go back and differentiate what we have up here. Okay, and for space, we know A acceleration equals multiplied by the power, so we're going to get a minus sign, so that's going to give us minus 3 over 4, t to the power minus 3 over 2. T to the power of 1, so that's just going to be minus 3 over 4. Now I wrote 6 out of 8 here because I was looking at this, but we know that's minus 3 over 4. J. So when t equals t, P equals acceleration, and I've rewritten my A acceleration here. That gets you your acceleration answer mark, not acceleration, that's our acceleration, and that's our answer mark. Right, so we have to link, this is related to this because acceleration is linked. So imagine as our triangle in terms of acceleration, that's our movement in terms of A, and they've given at a particular time t, this is our acceleration here, minus I minus 27. So as a ratio we should know this divided by this will equal this divided by this at this point. Hence we have minus 1 over 27 divided by our ratio here. This cancels nicely, this cancels nicely, and we can turn it over to 1 over 27. Now, some viewers unsure what to do here, so think about it. If that was t, and we want this t to the power 1, using the power rules, what can we power both sides by? Yeah, that's correct, because we want it to be minus 1. We multiply the powers by minus 2 over 3 to get 1 here. So that leaves us with t, and then we get a final answer, t equals 9. And now these types of questions, vectors and calculus, we should be getting a lot of marks from. And even if you can't get the first part, earn some marks in the second 2 parts by just doing it in low. And hopefully you can work out what to do from there. Well done.